What we're going to do is look at discrete random variables. We're going to be looking at probability distribution tables in order to find them. Discrete means that we can actually count the probabilities, and then we're going to eventually move into continuous random variables. So with discrete, we have two rules. Every probability has to be in between 0 and 1, and all the probabilities on the table have to add up to 1. So the first thing that we're going to be doing is we're going to be looking at each of our tables, and we're going to decide if it's a probability distribution table. If it is, we're going to put yes. If no, we're going to explain why it isn't. So for the first one, we see all the probabilities are in between 0 and 1. And then if we add them up, 1, 2, 3, 4, 5, 6, it'd be 6 out of 6, which is 1. So yes, it meets both the criteria. For the second one, automatically we see one probability over 1. We see one probability under 1. So the answer is no. And we have a probability that is over 1, and we have a probability that is under 0. So for the next one, what we are going to do is we see that all the probabilities are in between 0 and 1. 6, 7, 8, 9, 10, 11. We see that the sum of the probabilities is over 1. So the answer once again is no, because the sum of the probabilities is over 1. Now we're going to look at a probability distribution table, and we're going to answer each of the questions. For the first one, we see that there's no probability for 4, so we're going to add up each of our probabilities and subtract it from 1, and that gives us our missing value, which is 0.11. The probability of 1, we just look at the probability of 1, and that would be 0.22. Less than 2 includes 0 and 1, so that would be 0.63. Greater than or equal to 2 means it's equal to 2 and greater than 2, so we add up each of those probabilities, and that gives us 0.37. And then for the last one, a 3 or a 4, 3 or a 4, that gives us 0.23. So with this next one, what we're going to do is we're first going to fill in the probability for 0. So we add up each of the probabilities and subtract it from 1, and that gives us 0.67. So the probability of 0 would be 0.67. Less than or equal to 1 includes both of these, so that would be 0.84. And then what we have is greater than or equal to 3. So equal to 3 and greater than 3. So that would be 0.07. And then what we have is 1 or 3. So the probability of 1 or the probability of 3. And so when we add that up, we get 0.22. Now for example 4, we have to construct our own probability distribution. It says a family has 3 children. X represents the number of girls. Since it's 3 children, it could be 0 girls, 1 girl, 2 girls, or 3 girls, because it's up to 3 children. So the probability of 0 girls means boy, boy, boy. And we're going to assume that the probability of a boy or a girl is a half. So getting all boys would be 1/2 times 1/2 times 1/2, which is 1/8. Getting 1 girl would be girl, boy, boy, 1/2, 1/2, 1/2. Oops, not 1/3, 1/2. But there's 3 ways that it could happen. Either the girl is the oldest, the middle, or the youngest. We're not sure which is which, so it's going to be 3/8. Having a boy, boy, girl is going to follow the same 3/8. And having a girl, girl, girl is going to follow the 1/8. One way that we see that we're doing it correctly is if we add up all the probabilities, it should add up to 1. Now, the next thing we're going to do is draw a histogram. This is going back to Algebra 1. We have 0, 1, 2, and 3, and we're talking about number of girls. The highest probability is 3/8, so 1, 2, 3, and that would be 3/8, and we're talking about the probability. And so when we do our histogram, we have 1/8, we have 3/8, and we have 1/8. For example, 5, we have a bag, and it contains $1 bills, $5 bills, $10 bills, and we have $20 bills. The probability of a $1 bill would be 4 out of, and we have to figure out how many total. So 4, 3, 2, and 1. That would be a total of 10. So that would be 4 out of 10. 5 would be 3 out of 10. 10 would be 2 out of 10. And 20 would be 1 out of 10. Once again, if we're doing this correctly, this adds up to 1. And we're going to draw a histogram of this. The histogram, we're going to use intervals this time. So I'm going to go from 0, I'm going to go by 5s. So the first one is technically 0 to 4. And I'm going to go up by 4/10. This is the probability, and this is bill picked. So why I'm doing an interval is because I don't want to go by ones. That would take forever. It would be a long histogram. Then I have 10, 15, 20, and 25. Now, just as a reminder, when we're doing the interval, the first number is included, the second one is not. That's why the first one's 0 to 4. This is technically 5 to 9. Technically, this is 10 to 14, 15 to 19, and 20 to 25. 20 to 24. So for our first one, we have 4/10. Then what we have is 3/10. Then we have 2/10. And here we have a blank, and the last one is just going to be 1/10. So that right there is our histogram.